Hello everyone, I hope your week's off to a good start. In today's demo, we're going to be talking about how we can use Docker to create a reproducible environment to easily run our code anywhere. So to start, I have the finished code from last week's demo that Rahi did, um, or something close to it, pulled up in my editor here. What we're gonna do is use this. We're gonna put this in to we're gonna create a Docker image that is capable of running this anywhere. So how do we do that? To start off, we'll create a new file called Docker file, capital D, no file extension. So in our Docker file, we are going to start our Docker file by saying from Python latest. What this tells Docker to do is go to Docker Hub, which I'm going to talk about a bit later, and pull the latest stable version of the Python base image. So we're going to start with Python pre-installed and pre-configured in our environment. You can replace latest with more or less whatever version you'd like, if you'd like. Python version 3.7, for example. I tend to always be using the latest on my computer, so I'm going to use latest. We are then going to use the run keyword to execute a command in our environment that we're constructing. We're going to make user usr, sorry, that doesn't stand for user, /app. You can really create any directory you'd like, or even not, although it's recommended that you do. And then we're going to set our work dir to usr/app. So this is this has now set the sort of default directory of our environment to be that directory. Everything we execute will now be in that context. We will now copy ... So what this says is that we're going to copy everything from our current directory on our machine to the current directory, which is user app, on our in our Docker environment. After we've done that, so that what that's going to copy over is app.py, db.py, and requirements.txt. So then once we've done that, we can run pip install -r requirements.txt. So this will install all the dependencies on our machine. Just pretty straightforward. And then lastly, we will set the command that will be run by default when we launch our Docker image to python app.py to launch our server. So this is a complete Docker file capable of running this server. There's one more thing before I test it out. There's one more thing that I'd like to show you, which is we can create another file called .dockerignore. And this sets a list of files or folders that will be ignored by the Docker files copy command. So what I'm going to put in the Docker ignore is __pycache and VNV. Now, pycache you may have noticed popping up here every now and again sometimes. It's some kind of running artifact. I'm not entirely sure about the details that Python generates. It's just better to leave that where it is. It's because it's completely unnecessary. The VNV also, for the same reason that we don't zip virtual environments and submit them, because your virtual environments are useless to us when we're grading. The virtual environment from your local machine will be useless to Docker. So you may have noticed, in fact, that we are not using a virtual environment at all in the Docker file, because the entire image the entire point is to run this single application, there's no problem with installing our dependencies globally. Sometimes Docker is actually used as an alternative for virtual environments, and people develop directly in Docker, although that's not my preferred methodology. So now we've got this Docker file. How do we do something interesting with it? So I'm going to open up my terminal here. Let's see. Yeah, I'm going to open up my terminal here, and I'm going to execute docker build -t, and I'm going to call this demo 5 :test, and then dot. So this is going to tell us, this is going to tell Docker to build this this Docker file, this workspace. It's going to say we want to tag it as demo 5 test, and then use dot as the current directory as where we're looking for files and the Docker file. So it will find the Docker file, and here you can see it's downloading Python. Apparently I don't already have the latest Python image on my machine. So now we can see it's executing each individual step that we've told it to, installing all of the dependencies. So now that our image is built, we can run it. So we can say docker run, then we'll say -p 5000 5000. So we're going to -p stands for port. We're going to map port 5000 of our code to port 5000 on our machine. And I'm going to say demo 5 :test because that is how we tagged this image. I can run that. And then I can switch over to Postman here, and we can hit our get tasks route to see that we have no tasks currently. I can create a task, which is edit the edit the 5th demo, because I can count, and see that that's been added, and then go back here and resend this to see that I now have that task. So, popping back over to the code for a second, we can see I cannot quit from this. So what I'm going to have to do is actually kill my terminal instance and open a new one where I will run docker ps, and we'll see that demo 5 test is still running in the background. So we can see that demo 5 test is still running with this container ID. So we can kill this container by copying that and saying docker kill, and then pasting. And now there are no containers running. If we would like to be able to quit, now usually it's somewhat advantageous to run our containers in the background persistently. We don't particularly want to have them tied to our terminal, but if you do want to have it tied to your terminal, then what you can do is run -it to make an interactive instance. That will start the server just as before, and it'll work just as before. However, it will be quittable, and running docker ps, we can see that it is not still running in the background, if that's what you're looking for. So configuring Docker through the command line every time is a little bit unfortunate. Luckily, we don't have to, because we can use what's called a Docker, what's called a tool called Docker Compose. And so we set that up by creating a new file called dockercompose.yml. docker_compose.yml. And what we'll do in here, we'll specify that this is version 3. That's the latest-ish version of the Docker Compose specification. And so we'll specify that we want to have... so what you can do with Docker Compose is coordinate multiple images and share storage between them, share volumes, storage volumes between them, and configure their network access and lots of things really specifically. In this case, we're only going to have one service, but we could declare here a lot of services. We're going to have one service called demo, and the demo service is going to use the image from our machine demo5 test. And then we will also specify our port mappings. We're going to say 5000 colon 5000. It's possible that you may need quotes around your 5000 5000 in the command line as well, if that didn't work for you. On Linux, however, that is not the case. So this Docker compose file will instruct Docker on how to create our system for us. So what we will do is run Docker Docker compose up. Yes, I have accidentally named my file docker_compose when it should be named docker-compose. We will run docker compose up and see that now we have this container running. Now, however, we do have sort of the opposite problem from before, where when we Control-C, it will actually interrupt and end the container. Through docker ps, we can see that nothing is running. However, if we do docker compose up-d, it will start a daemon process. I really haven't figured out how to pronounce that properly in the background. And we can now see that we have demo5 test running in the background. Ports properly configured, 0005,000 mapped to our local 5000 TCP. Or more so, our local 5000 mapped to the internal 5000 TCP, I believe. So that's very cool. There's one last thing that we might want to do, and that is push to Docker Hub. So let's talk about Docker Hub for a moment. I'll just kill this so that I don't forget that it's running and have it running for the rest of my life. Great. This is Docker Hub. Specifically, this is the Python organization on Docker Hub, which is where we got the Python base image that we built our image off of from. You can actually just pull the Python image and run it directly and have an image that runs Python. And that allows you to do things like, actually, if we go back to VS Code for a second, I actually will restart this process because I would like to demonstrate that what you can actually do with these containers is you can say docker exec -it, your container ID, and then bash. And what this will do is actually open a terminal inside of the Docker container. So we are now in the working directory where of our running server, and we can inspect the objects in here and do things to it if we need to change, test, examine on the fly, which is very convenient. Control-D or exit to exit. So what you could do is, if you wanted a simple, fast Python setup, what you could actually do is, I'm just going to kill this real quick. What you could actually do is docker pull Python. So seeing that we already have Python latest pulled, we can docker run -it Python. And just like that, we're put right into a Python interpreter, but not the Python interpreter running on our machine, rather the Python interpreter that we just pulled from Docker. And similarly, once we've pushed our own services to our own Docker images to Docker Hub, other people can easily pull and run them. Python is not a server, but in our case, it would be a server, and so running it would cause the server to run on their machine. Python is a foreground process, so attempting to run it without IT won't do anything because it will immediately exit, as we can see in Docker PS. So hopping back to the browser, that's sort of what's going on here. So let's say we want to push our own server. I do want to push my own server. So I'm going to head over to my profile. In fact, I'm going to head over to repositories. I'm going to create a repository called demo5. And it's going to be public because I have a limited amount of private repositories. It gives us a handy list of what needs to happen here. So what's going to happen is I'm going to create this repository, and I'm going to head back over to code. So this repository is Grebnir, my last name spelled backwards, /demo5. So in order for Docker to know how to deploy this or know how to push this, we're going to need to re-tag it. So we're going to say docker tag demo5 test as Grebnir /demo5 test. Now, the thing after the colon is actually optional. I just like to put it there to sort of denote that I'm just messing around, so I know what this version is. I'm going to do a couple other things. I'm going to Docker login, because I actually haven't logged into Docker on this machine before. Now I'm logged in. So now if I run Docker images, I'll see I have a lot of images, but oh boy, I have a lot of images. Are these in any kind of order? Yes. We can see now in addition to demo5, I have Grebnir /demo5 as the repository. Now, very simply, I can docker push Grebnir /demo5 test. That'll take a moment. There we go. And now we can hop back to the browser, refresh, and see, after this finishes loading, that I have a tag in this repository. Back on my profile, I have this repository viewable. You can go visit it and pull the image and run it yourself if you'd like. Use it in your own Docker Compose files. But yeah, so now this is publicly available to anyone, and they can get my exact environment, no configuration necessary. So I hope you had fun with that. It's a pretty interesting topic. As a closing note, I will say what I probably should have said at the beginning, and say that if you are on Windows, I'm sorry, I feel your pain. Docker for Windows is heavily subpar. You're going to want to consider either using a virtual machine or using the Windows subsystem for Linux. Those have some various pros and cons that I would be happy to discuss with any of you on Slack. Those of you on Mac and Linux, however, should have very little trouble getting this whole thing up and running. Anyway, I think that's it for this week. I hope you have fun on the assignment, and feel free to reach out on Slack or come to office hours if you have any questions about anything. Yeah, have a great week.